We are going to continue on talking about end behavior and multiplicities. This is part 2. Specifically, our goals are to find the zeros of a polynomial function and identify the multiplicity of each zero, and we'll define those terms. Find the x-intercepts of a polynomial function, and then we're going to use the zeros, multiplicity, and end behavior from the last lesson to sketch a graph of a polynomial function. Okay, so recall that the zeros are x values, and it's x values where f of x is equal to 0. Okay, so for instance, when we talk about the occurrences of zeros, that is the multiplicity. So in this first example, find the zeros of x plus 2 times x minus 1 times x plus 3. So we would set this equal to 0, and then we would set each factor equal to 0. Okay, so this first one gives us x is negative 2. Then we set x minus 1 is equal to 0. This is x is equal to 1. And then we said x plus 3 is equal to 0, and x is negative 3. Okay. Now, each of these zeros only occurs one time, and so that means that each of these zeros has a multiplicity of 1. And the reason that it only occurs one time is the exponent of each factor is just 1. Okay, and you'll see a difference in the next example we do. Okay, so in the second one, find the zeros of f of x is equal to x to the 6th times x minus 2 squared times x minus 3 to the 4th. We're going to set this equal to 0. And we'll set each factor to 0. So x to the 6th equals 0, just is going to give us x is 0. Okay, we have x minus 2 is our factor equal to 0. This gives us x equals 2. And then we have x minus 3 equals 0 and x equals 3. Now each of these has a different multiplicity. Okay, I should have just set x equal to 0. So x to the 6th power, this 6 is going to give us the multiplicity. This 0 occurs 6 times. Okay, so this x equals 0 has a multiplicity of 6. For x equals 2, this has a multiplicity of 2. And for x equals 3, this has a multiplicity of 4. Okay, so another way to think of it is what the exponent of the factor that the 0 came from is. Okay, so example 1, find the zeros of the polynomial function and state the multiplicity of each. Okay, so we've got one factor, we've got x is equal to 0, x minus 1 equals 0, and x plus 9 equals 0. Okay, so from x equals 0, we just get x is 0. From x minus 1 equals 0, again, we add 1 to both sides, we get x is 1. And from x plus 9, we subtract 9 from both sides and get x is negative 9. Okay, so our smallest zero, the smallest number here is negative 9, and that has a multiplicity. The exponent there, if you don't see it, it's just 1. Okay, so that occurs one time. The middle zero is x is 0, and that has a multiplicity of 7. Okay, because that's what the exponent is, or that 0 occurs 7 times. The largest zero is 1, and that has a multiplicity of 2, again matching it with the exponent. Okay. Example 2, find the zeros of the polynomial function and state the multiplicity of each. So here we have to be careful. There is a 3 on the outside, okay, and really I should be setting this equal to 0 to find the zeros. That 3 doesn't have an x with it, so we don't set it. If we set 3 equal to 0, it doesn't make any sense, right? So we're setting everything that has a factor or that has an x equal to 0. So we have x minus 1 equal to 0, x plus 2 equals 0, and then we have x is 0. Okay, so again, we solve each one. We get x is 1, x is negative 2, and x is 0. So our smallest zero is negative 2. That has a multiplicity of 4. It occurs 4 times. That's also the exponent of the factor that it came from. The middle zero is 0, okay, and that has a multiplicity of 5. The exponent of x is 5. The largest zero is 1, and that has a multiplicity of 2. Okay. So remember that zeros and x-intercepts are connected. So we just talked about that our zeros are the x values, where f of x is equal to 0. These are also our x-coordinate of the x-intercept. Okay, so if we have a graph, something like this, let's say this is negative 4, 0, negative 1, 0, 3, 0, 5, 0. Okay, so the zeros would be negative 4, negative 1, 3, and 5, because that's where the y value is 0. But the x-intercepts is where the graph intersects the x-axis. The y-coordinate is 0. And so our x-intercepts are ordered pairs, negative 4, 0, negative 1, 0, 3, 0, and 5, 0. Okay, so there's a connection there with multiplicity to the x-intercepts and the graph. So if a 0 has an even multiplicity, the x-intercept, or it'll be tangent, it'll touch the x-axis. Okay, if the 0 has an odd multiplicity, our graph is going to cross the x-axis. So it tells us what the graph is doing at those x-intercepts. So multiplicity helps us with these x-intercepts. And it also helps us, so in the last lesson we talked about end behavior, and we didn't know what was going on in between. But the zeros are going to help us figure out what's going on in between the end behavior. Okay. So some examples. Determine whether the statement is true or false. The graph of f of x is equal to x minus 7 to the 10th times x plus 8 to the 9th is tangent to the x-axis at negative 8, 0. So we're talking about what's happening with the x-intercept. We need to determine our zeros and the multiplicity of each. Okay, so if we set our polynomial equal to 0, we have x minus 7 equals 0 and x plus 8 equals 0, which gives us 7 and negative 8, which means our x-intercepts are 7, 0 and negative 8, 0. So that's where they're getting this negative 8, 0 from. Okay, now our 0 of negative 8 has a multiplicity of 9, and our 0 of 7 has a multiplicity of 10. And we're interested specifically in our 0 of negative 8 because that's what this question is asking for. The multiplicity is odd, which means that the graph is going to cross the x-axis at negative 8, 0. Okay, so this statement would be false because it's not tangent because the multiplicity of the 0 is odd. So what we're going to be able to do now is put everything together. So we're going to put together our end behavior, which remember is based on our leading term. We're going to put together our zeros, the multiplicity of that to talk about our x-intercepts, and that's going to tell us whether the graph crosses at the x-axis or is tangent. Okay, tangent just means it touches, so I should draw a picture of that. Tangent would mean that it just touches, it doesn't cross. Okay. So example 1, sketch the graph of the polynomial function. Okay, so we need to figure out our leading term. Remember, we don't have to multiply this out. We can look at what would happen just with the first term if we did. And we would get x cubed. If you want to prove it to yourself, I do encourage you to multiply it out. Okay, so this means that our end behavior is going to look like this type of squiggle. Okay. In terms of our 0 and multiplicity, it's like we set this equal to 0. So we have x minus 1 equals 0 to give us x equals 1. And then we have x plus 1 equals 0 to give us x is negative 1. Okay, and the multiplicity, so the multiplicity of x equals 1 is 2, and the multiplicity of x equals negative 1 is 1. Okay, so now we can talk about our x-intercepts in the description. So our first x-intercept is 1, 0. Our multiplicity is even, so this is just going to touch the graph at 1, 0. Okay. We also have another x-intercept of negative 1, 0. And since our multiplicity is odd, it's going to cross the x-axis at negative 1, 0. Okay, so what I recommend doing is plotting the x-intercepts first, and then we'll kind of connect everything together. Okay, so our first x-intercept is 1, 0. Our second one is negative 1, 0. Okay, and our graph has to end up like this. Okay, so now it's time to piece it together. It's going to touch here, and then it's going to cross here. Okay, and I didn't connect them very well. Okay, this graph doesn't tell us how high our loops are going. So for instance, it doesn't, none of the tests we've talked about talk about, does this go up a lot? Does it say down or what? But it does tell us, okay, we have to cross at negative 1, 0, and we have to touch at 1, 0. Okay. Try another example. So sketch the graph of the polynomial function. So we have x times x minus 3 times x plus 4 squared. So with our leading term, x plus 4 squared is going to give us x squared plus a bunch of stuff. Okay. If we distribute this, this is x squared plus whatever. And if we multiply these together, we'll get x to the 4th. Again, multiply it all out to prove it to yourself if you want to do that. And if you have questions about that, feel free to ask me. So we have x to the 4th. So our end behavior is it's going to be a smiling graph. Okay. So our zeros, so we're setting this equal to 0, so we have x is 0, x minus 3 equals 0, and x plus 4 equals 0. Okay, so from here we get x is equal to 0, and it has a multiplicity of 1. We have x is equal to 3, and it has a multiplicity of 1. And we have x is equal to negative 4, and that has a multiplicity of 2. Notice also if you add up the multiplicities, you get the degree of the polynomial. 1 plus 1 plus 2 is 4. Okay, so that's another way to help with the leading term. So with our x-intercepts in our description, so we have one x-intercept at 0, 0, and it's going to cross. We have another x-intercept at 3, 0, and it's also going to cross because the multiplicity is odd. And then we have another x-intercept at negative 4, 0, and this is just going to touch or be tangent to. Okay, so we plot our zeros first. So we have 0, 3, and okay. And so when we're graphing this, it's just going to touch at negative 4, 0. And I would pick a starting point too. So start at one side of the end behavior, either on the left or on the right. But I know my end behavior. Okay, so I'm going to start there. It's just going to touch, but then for these other ones, it's going to cross. And then I have to end up with my end behavior. Okay, so this has the proper end behavior. Both sides are going up as x goes to infinity and as x goes to negative infinity. Okay, thank you for watching. If you have any questions, feel free to reach out to me.